So in the last video we looked at vertical asymptotes by talking about limits. In this video we're going to look at them a different way. A way that we can do them a little bit quicker. So consider the function here, x minus 2 over x cubed minus 4x squared plus 4x. So the first step is still the same. We need to figure out where our potential vertical asymptotes are. And those are going to be where the function is dividing by 0. So x cubed minus 4x squared plus 4x equals 0. We can pull out a common factor of x, so that we're left with x times x squared minus 4x plus 4 equals 0. And then we can keep factoring a little bit further, because x squared minus 4x plus 4 is actually a perfect square. That's going to factor as x minus 2 times x minus 2. Right? Things that multiply to be 4 and add together to be a negative 4 will be a negative 2 and a negative 2. So we factored the denominator, that equation equal to 0, and that gives us two solutions, two potential vertical asymptotes, x equals 0 and x equals 2. Now, what we did in the previous example is we looked at them individually. What happens as I approach 0? What happens as I approach 2? To see what kind of a limit we're dealing with, so whether we knew it was going to be a vertical asymptote or not. And one of the telling things that happened was in the problem where it wasn't a vertical asymptote. If I go back here, in this problem here where it wasn't a vertical asymptote, that 0 factor was removed from the problem. It no longer existed in the bottom, and that led to a hole in the graph. And so with that idea in mind, let's reduce our fraction as much as we can. So I've already, in solving the equation for the denominator, I've already factored the denominator. The numerator is already broken down. So we can go ahead and simplify this fraction by canceling out one of those x minus 2 factors. But there's still an x minus 2 factor in the bottom. So if you had been doing the limit for that as x approaches 2 from the left or the right, you'd have reduced that, but then you'd still have a limit which would actually turn into a number over 0. And so once we've canceled out those 0 factors, anything that remains in the denominator as a factor, as a 0 of the denominator, is going to be a vertical asymptote. And so in this case, what we do is we reduce it first, and then look and see what's left. And in this case, we see that both 0 and 2 are still factors of the denominator, and so both of those are vertical asymptotes.